Today we're going to do Chapter 1, Lesson 4, Multiplying Integers. Our essential question, is the product of two integers positive, negative, or zero? How can you tell? In order to answer that question, you're going to have to understand the key idea for this lesson, which is going to give you the rules for multiplying integers. When multiplying integers with the same sign, the product of two integers with the same sign is always going to be positive. So if I have a positive times a positive, my answer is a positive. If I have a negative times a negative, since the signs are the same, my answer becomes positive. Multiplying integers with different signs. The product of two integers with different signs is negative. So for example, if I have a positive times a negative, since my signs are different, my answer is negative. If I have a negative times a positive, again, since my signs are different, my answer is negative. So all you're doing is multiplying the numbers and following those two rules. Same sign, always positive. Different sign, always negative. So if we look in example 1, we're multiplying integers with the same sign. All right, so since they have the same sign, a negative times a negative, I'm going to go back to my rules for the same sign. My answer is going to be a positive. 5 times 6 is 30. Negative 5 times negative 6 is also 30. Two negatives will give you a positive. In example 2, different signs. A, I'm looking at 3 times negative 4. Well, I know 3 times 4 is 12. Therefore, 3 times negative 4, since my signs are different, my answer would be a negative 12. In B, my signs are different again. Negative 7 times 4. 7 times 4 is 28, but negative 7 times positive 4 would be a negative 28. Different signs always give me a negative answer. So I want you to make sure that you have those rules down. Same sign, positive. Different sign, negative when you're multiplying. Pause the video and see if you can complete the on your own problems 1 through 8, then come back and check them. Number 1, 5 times 5. A positive times a positive would give me a positive. 5 times 5 is 25. Number 2, again, same sign. Positive times a positive is a positive. 4 times 11 should have given you 44. Number 3, a negative times a negative. We're still looking at the same sign rule, so my answer is going to be a positive 9. Number 4, a negative times a negative. Well, again, same sign is going to give me a positive answer. That would be positive 56. Number 5, my signs are different, therefore my answer should be negative. Negative 24. Number 6, my signs are different. My answer should be negative. Negative 24 as well. Number 7 and 8, we're looking at 3 different integers being multiplied. So we could break it up. Negative 10 times negative 6. Two signs that are the same. That would give me a positive 60. Positive 60 times 0. Anything times 0 is 0. If you notice that 0 from the get-go, you would know that your answer is also 0. Because whenever you multiply by 0, you will always get 0 as your answer. In number 8, I'm multiplying 3 negatives. So when I look at my first 2 negatives, a negative times a negative is a positive 35. And a positive 35 times a negative 4 is going to give me a negative 140. And we could have switched that as well. You could do negative 5 times negative 4. That would give you positive 20. And positive 20 times negative 7. Your signs are different. You still get negative 140. Right, sometimes it's easier to multiply where you're going to end up ending in a 0. And with multiplication, since it follows the commutative property, we can switch the order and still get the same answer. Moving on to example 3. We're now looking at exponents. So for a quick review of exponents, when we're talking about exponents, we talk about a number that we consider our base that is raised to a certain exponent, which is that small number at the top. For example, you might have 2 to the third power. 2 would be your base, and this 3 would be your exponent. What does that mean? Your exponent tells you how many times to multiply the base by itself. So 2 to the third power is really 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So the answer to 2 to the third power would be 8. So what happens with negatives now, there's two different things that you're going to see. If you look at A and compare it to B, in A, notice we have parentheses around the -2. So this would be read as -2 squared, or -2 to the second power, which means that you're doing -2 times -2. But in B, notice there's no parentheses. So they're not asking you to square -5. They're asking you what the opposite of 5 squared is. That's how we would read that one. The opposite of 5 squared, as opposed to an A where we would say -2 squared. So there's a difference when you see parentheses versus not seeing parentheses. So in A, I'm going back to A, -2 times -2, my signs are the same, therefore my answer is +4. But in B, if I want to write that out, it's like saying the opposite of 5 times 5. 5 times 5 is 25. The opposite of 25 would give me -25. So when you have a negative sign out here with no parentheses, it's asking you for the opposite of a positive answer. So your answer will always end up being negative. That's not true over here. That will depend on your exponent. So here I have an even exponent. An even exponent, when you have a negative number, should give you a positive answer. Watch what happens in C. In part C, notice I have an odd exponent. So I'm really asking myself the -4 cubed, which is -4 times -4 times -4. So a -4 times a -4 gives me a +16. My signs are the same. Then I'm doing +16 times -4. Now my signs are different. So my answer is going to end up being negative, and that gives me -64. So a rule of thumb, with parentheses, when you have an even exponent and you have a negative number being raised to an even exponent, it should yield a positive answer. When you have a negative base to an odd exponent, it's going to end up giving you a negative answer, because a negative times a negative gives me a positive, like you saw here, and then a positive times a negative. My signs are now different, which gives me that negative answer. So looking at numbers 9 through 12, see if you can follow those rules. Pay attention to whether or not you have parentheses like you do in number 9, like you do in number 10, versus not having parentheses like you do in 11 and 12. See if you can answer those 4 questions. Pause the video and then come back and check your answers. In number 9, I would read that as -3 squared, which is -3 times -3, which would give me a +9. In number 10, I would read that as -2 cubed. So I notice it's an odd exponent, so I should be reminding myself a negative number being raised to an odd exponent should yield me a negative answer. Let's see if that happens. -2 cubed would be -2 times -2 times -2. -2 times -2 is a +4. +4 times -2, my signs are now different. My answer should be -8. So we can see a even exponent gave me a positive answer, and this odd exponent gave me a negative answer. 11 and 12 are a little bit different. There's no parentheses. So number 11, we would read the opposite of 7 squared. So if I want to write it out, I've got the opposite of 7 times 7. 7 squared is 49. The opposite of 49 would be -49. And number 12, we're looking at the opposite of 6 cubed. Excuse me. So I'm doing the opposite of 6 times 6 times 6. 6 times 6 is 36. 36 times 6 gives me 216. The opposite of 216 would be negative 216. All right, so please make sure you recognize the difference between your base being in parentheses versus it not being in parentheses. In example 4, we're looking at taxis in service. The bar graph shows the number of taxis a company has in service. The number of taxis decreases by the same amount each year for 4 years. Find the total change in the number of taxis. So if I look at my table, I can see my bars are constantly decreasing. They're getting smaller. They're going down. By how much are they going down? They're going down by 50. What number represents down 50? That would be a negative 50. And it's asking me to find that change over a 4-year period. So it's going down 50 for 4 years. Negative 50 times 4. How many taxis are being decreased after 4 years? My signs are different, therefore my answer will be negative 200. So the taxis are going down by 200 after 4 years. The on your own problem. A manatee population decreases by 15 manatees each year for 3 years. Again, we're talking about a decrease of 15 for 3 years. Find the total change in the manatee population. See if you can write an equation and solve. Pause the video and come back and check your answer. So in number 13, since we are decreasing by 15, we use the integer negative 15 to represent that decrease. Each year, each means to multiply. For 3 years, my signs are different, therefore my answer is negative, and 15 times 3 would yield me 45. Therefore, the manatee population is decreasing by 45 after those 3 years.